In this video, we're gonna learn about uh, the future value of a lump sum compounded continuously. In previous videos, we have learned the future value of a lump sum or the future value of a one-time investment uh, that is compounded discrete amount of times annually or per annum. That is, we have tried to see what our one-time investment will be worth in the future if it's compounded, say, 4 times a year, that is quarterly, 2 times a year, maybe semi-annually, or if it's just compounded one time per year, that is annually. So in this video, we're going to see what the future value of a single time or one-time investment will be in the future if there is an infinite amount of compounding per year. So the formula for the future value of an investment that's compounded continuously is given by the future value after n, or n number of periods, is the present value multiplied by e to the power of the stated annual interest rate times the number of period. So E is called the Euler's constant in mathematics, and this Euler's constant is just the base to the natural logarithm, and it's given by the sum n from 0 into infinity of 1 over n factorial. This means E is 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus up to infinity. So if you add this series, you'll get E. And E is a constant, as we said, and that value is about 2.71828, and it just goes on like this. So let's just see an example. This video might be a little longer, so I might divide into chapters later on. So let's say you at time is equal to 0. Today you've invested present value, you've invested $10,000, right? And let's say you've invested that into a certificate of deposit account at a bank, and that certificate of deposit gives you an annual interest rate or a stated annual interest rate of 8%. That's about 0.08. And the maturity period for this certificate of deposit is 2 years. So now the question is, with continuous compounding, what's your investment, your 10,000 investment will be worth after 2 years? So using this formula, the future value after 2 years is, again, PV times e raised to stated annual interest times n. This is 10,000 times e raised to 0.08 times 2. This is 10,000 times e raised to 0.16, and this will be about 11,735 and 11 cents. Now, so if you have a stated annual interest rate of whatever amount, let's say 8% again, so with different types of compounding, if the compounding, depending on what the compounding is, if the compounding is annual or semi-annual or quarterly, or it could be monthly, we find different types of different amounts of future values, right? So you have some present value, you have some initial investment money you put at an 8% of stated annual interest rate. So depending on what type of compounding is used, we might arrive at different future values for that present value. So let's see that. For example, let's say you have invested uh, $1 today, right? So, and let's use a stated annual interest rate of 8%, right? And let's say we have previously learned that whereas RS is the stated annual interest rate, RS over M is the periodic interest rate, right? Where M is the number of compounding per annum. For example, if M is 4, then it's a quarterly compounding. If M is 2, it's a semi-annual compounding. If M is 12, then it's a monthly compounding, right? So RS over M here is the periodic interest rate. So let's do, let me just do here, you have present value. Here you have the periodic interest rate, which is RS over M. And let's have M times N here. And you have a future value. So M times N is simply the total number of compounding for that N period. For example, if N is 2 years and M is 4, that means this investment is compounded quarterly for 2 years, right? So that's what MN means. So let's see, we invested $1 today, right? At an 8% of stated annual interest rate. And if this is compounded annually, which means M is 1, then this is equals to, let me just give myself some space here, MN, and here the future value, and also the stated annual interest rate is 8%. And let's talk about how much we'll have at the end of the first year. So N is 1, RS is 8%, and N is 1. So at the end of the first year, so 0.8 divided by 1 gives us the annual interest rate. That is 0.08, right? So M times N is 1 times 1, which is 1. Okay, so this will give us at the end of the year $1.08. So let's say we have the same investment. Okay, so that is $1, same stated annual interest, but this time it's compounded semi-annually, which means it's compounded 2 times a year. Now this will give us about 4%, right? This is the same as 0.08. Let's say this is 8%. 0.08 divided by 2 is 0.04, which is 4%, right? So in this case, our M is 2, our N is still 1, right? And this will give us about 0.816. So at the end of the first year, with semi-annual compounding, a $1 investment with a 0.08 stated annual interest will yield or will be worth about 1.0816. Let's keep on going. Let's say we have invested the same amount of money with 8% stated annual interest rate, but this time we are compounding it quarterly, that is 4 times a year, right? This is 2%, or 0.02, which is 2%. Now our M is 4. Still, again, we're talking about a 1-year period, so our N is 1 and our MN is 4. This will be worth about, at the end of the first year, this will be worth about, okay, let me again give myself some space here. right? This will be about 1.082432. Again, let's say we have a $1 investment with an 8% stated annual interest rate. Let me just do this. I missed. All right, RS over M. This is simply the periodic interest rate as described here. So now we are compounding it, let's say monthly. That means it's compounded 12 times a year, 12 times in a single year. So the monthly interest rate is simply 0.0 0. So let me just pull out my calculator. 0.08 divided by 12. 0.08 divided by 12. So give me 0.006666. 0.00666. Okay, that's about 0.12, 0.6%, right? 0.67%. Okay, let's do 0.67%. Okay, so now we're compounding it 12 times a year in a single year. Our MN is 12, and this will give us a future value of about $1.083. Okay, now let's do daily compounding. So we invest $1 today at an 8% stated annual interest that's compounded every day, which is daily, right? So 0.08 divided by 365, I think that will be about 0.0219%. And our MN will be 365 times 1. This is 365. So after a year, or at the end of the first year, this will be worth about 1.083278. All right. Now the last one is after daily compounding. The last one will be continuous compounding, right? So let's say we've invested today $1 at an 8% stated annual interest rate, but divided by how many times is it compounded? Almost infinite amount of times, so compounded continuously within a year. So M has no value, so we can't calculate RS over M, or we can't calculate the periodic interest rate. It's impossible. Again, M is approaching infinity. In this case, M approaches infinity, so we can't have a value for these two items here. So at the end of the first year, a $1 present investment or current investment will be worth about 1.083287 at the end of the year. So now this is just simply what we call the effect of compounding frequency on future value, right? Okay. So now you've understood this, let's see a different concept. So let me just change my pen to blue. So if you invested $1 today, right, at a stated annual interest rate of 8.16%, compounded annually, that is one times a year, this will have the same future value as a $1 investment invested at a stated annual interest rate of 8%, that is compounded semi-annually. So a dollar one present investment today, if you put a dollar one into an account that pays you an 8.16 annual stated annual interest compounded annually, has the same future value at the end of the year as a dollar one investment that is discounted with an 8% stated annual interest that is compounded semi annually. So this leads us to say that for a stated, or this is simply means RS, the stated annual interest rate of 8%. Again, let me change my pen. So for a stated annual interest rate of 8% compounded semi-annually, which is this one, semi-annually, we say the EAR, or the effective annual rate, is 8.16% because it has the same future value as an investment that's compounded annually at a rate of 8.16%. I hope this is clear. So the effective annual rate is, the rate at which it's compounded annually to have the same future value as an investment that's compounded semi-annually with the same with a different stated annual return. So with this, we can just go to the next topic, which is stated versus effective rates, right? So what happens with what's the one thing about a stated annual interest rate? The one thing that we observe about the stated annual interest rate, that it cannot directly give us the future value. We have to convert it into a periodic interest rate. A periodic means that period, maybe quarterly, semi-annually, annually, and we do that by dividing it by m, right? So let's say the periodic interest rate is the stated annual interest rate divided by m, right? That's simply, so if RS is, again, 8%, which is 0.08, if that investment is compounded, let's say semi-annually, 2 times a year, then our periodic or semi-annual interest rate will be simply be RS over M, which is 0.08 divided by 2, which is 0.04, which is the same as 4%, right? So I hope this is clear. Now, we've seen here that a $1 investment that is invested with a discount rate or with a stated annual interest rate of 8% compounded semi-annually will give us a future value of 1.0816 at the end of 1 year, right? So let's just restate that here. You have a present value of $1 with a stated annual interest rate of 8% compounded semi-annually will give you a future value at the end of the first year. That means n is equals to 1. It will give us 1.086. So initially we invested $1, right? Right? At the end of the first year, we got 1.086. So how much interest did we get? The interest for the 1-year period is given by, right, FV1, that is the interest. So for that 1-year period, how much interest did we get? FV minus PV, FV1 minus PV. So that is 1.086 minus $1. So over the past year, we have obtained an interest of about 8 cents, 8.16 cents. Okay, this is what's called the effective annual rate, which is 8.16%. So you can see that while the stated annual interest rate is 8%, the effective annual rate is 8.16%, right? So this will give, by this, we're going to come up with a formula for the effective annual rate that incorporates the periodic interest rate. So let's just go a little, do this a little with a formula. So EAR equals 1 plus RP raised to M minus 1. Again, let's do this. EAR is the effective annual rate, right? RP is the periodic, whatever period that is, quarterly, monthly, daily, periodic interest rate, right? And this RP is given by RS over M, where M is how many times it's compounded per annum, right? And where M is the number of times an investment is compounded per annum, annually. This is a very important distinction, right? So we have this formula right here. Right? So the effective annual rate is given by this formula, where RP and M are the periodic interest and the number of times an investment is compounded annually or per annum. Let's go back to this example that we have here. For a stated annual interest rate of 8%, that's compounded semi-annually, right? So for an RS, that's 8% or 0.08. That's compounded semi-annually. Our periodic interest rate is 4%, right? 0.08 divided by 2, 0.04. And this is same as 4%. So let's use this with this formula. We said EAR equals 1 plus RP raised to M minus 1. So this is 1 plus RP is 0.08 divided by 2 raised to M semi-annually minus 1, right? This is simply 1 plus 0.04 minus 1. And this is equals to 1.04. Wait, there's 2 here. Square minus 1. And this will give us 0.0816. This is 8.16. So this is how we calculate the effective annual rate from the stated annual rate, the stated annual interest rate, in the periodic interest rate, or the periodic interest rate, because the periodic interest rate, we get it from the stated annual interest rate, dividing the stated annual interest rate by M. Now, this also extends to continuous compounding. Now, this EAR formula also extends to continuous compounding. What does that mean? That means, let's say we have a stated annual interest rate of 8%, but in this case, our M approaches infinity because our investment is compounded continuously throughout the year, right? Now, the formula that we have for our future value for continuous compounding is present value times e raised to rs n. Now, if we go back to the table that we have here, right, with a continuous compounding of $1 investment, at the end of the first year, we're going to get about 1.0833. So our future value, so for initial investment of $1, right, and a stated annual interest rate of 8% or 0.08, right, where it's m approaches infinity, which is continuous compounding, and n is equals to 1. Our future value at the end of the year, the future value of this dollar is about $1.0833. All right. So how do we get this? So EAR for this case is given by e raised to rs minus 1. This is e raised to 0.08 minus 1, and this will give us 0.0833 or 8.33%. Again, here we have an initial investment of $1. At the end of the year, we got 1.0833, and the effective, the interest we got is this 1.0833 minus $1, which is 0.0833. This is the total interest that we obtained for the first year, or at the end of the first year with continuous compounding. And 8.33 will be the effective annual rate for this type of investment that has these characteristics. I hope this was helpful.